Hey guys, welcome to my final presentation for my research project. I wanted to give a quick recap about what I talked about last time. Since we have so many presentations, I figured that people might forget the specifics of what I was doing. So the question I was basically trying to answer was if I'm an Etsy shop owner, Etsy being obviously an online marketplace for small shops and creators with mostly handmade goods. If I'm an owner of one of these shops, what can I change about my shop to get the best possible average review? So for previous work that I looked at, I obviously talked in detail about these three different research papers last time, but the key takeaways I'll just go over. So most of the previous work has been done by actual internal Etsy researchers. So I was wondering kind of if that might result in some kind of bias towards Etsy. So I kind of wanted to do my research from more of a shop seller's perspective, as opposed to obviously an Etsy perspective. The previous work didn't have exactly the same target as mine. It was targeting various other things such as like sales and stuff like that, but I specifically wanted to target review because of the average review, because of the impact it can have on whether or not the shop shows up high in Etsy search results, and then also some research that I read about how average review has a really big impact on especially how younger people, the decisions that they make about what to buy. And then finally, the data sets from the previous work was not publicly available, so I decided to gather my own data, which I'll talk about in a bit. So for my proposed method, I kind of have the steps listed out here of what I plan to do. Over there on the left, you can see my target, which I was calling the average stars per month. So it's basically the average number of review stars, reviews being between 1 and 5 stars, that the shop receives per month that it has been active. So over there on the right, you can see my 4 steps. My first step was going to be to collect a data set of randomly selected active Etsy shops. Next, I was going to tune a random forest model using a subset of the features that I gathered in step 1. 3, obviously, I'd use the model to predict the target. And then 4, I wanted to determine the 10 most important shop settings that a seller could change to have the biggest impact on the target. So for data collection, I already kind of touched on this last time, but I used the Etsy public API to collect my data set. I used these 3 endpoints you see there on the left. The first one was just kind of to get the general shop metrics, and this was also how I determined which shops I could keep as part of my data set and which ones to throw out. The second endpoint was to get more details about the shop listings, and the third one, the about section, is like the story, like why the seller created the shop and information like that. So because I was limited by Etsy to 20,000 requests per day to the API, as you can imagine, it took several days of me kind of running the script every night to collect enough data. The IDs, the way I got the ID was basically just to randomly generate one in the range, which was between 10,000 and 30,000. And it was just like an integer was the ID for the shop. So I just randomly generated one each time, grabbed the shop, and then ran it through this algorithm here on the right, algorithm 1, which is just pseudocode, basically to figure out whether or not I could include the shop in my data set. The parameters I used to determine whether I could use a shop was, first of all, whether it was active. So if it was no longer active, it was hard for me to calculate my target because I couldn't really tell like how many months the shop had been active based on the API. So I had to find shops that were currently active so I could calculate the months active number that I needed for that target. Also, I would check whether the shop had active listings or if it accepted custom requests. Because so active listings obviously is listings on the shop, so various things that people can buy. Custom request is when there's a button that you can click and type in basically what you want, and the seller will make it for you. So I considered like the presence of both of those things to indicate that it was active. The final thing I checked was whether or not the shop had reviews, which I obviously needed as well to calculate the target. So out of 33,000 records that I examined over several days, only 3,257 were usable for my data set. So this is a little bit of code. I didn't want to like actually scroll through my code and talk about it in detail, but here's a couple of snippets of like the important pieces with the data collection. So the top is just basically implementing algorithm 1, this should keep method. And then the bottom there is once I had all of the data, I did some processing on it to turn it into values that obviously the model could use, so those being numeric. You'll see my features on the next couple slides, but basically I would either use or convert stuff to like a Boolean of whether or not the shop has a certain field filled in, or I would get the length or in like characters of certain fields. So here's the selected features, like I mentioned. I selected quite a few different things, and they're all either going to be Boolean or integer. So some of these I was particularly interested in, such as like whether the total number of listings that a shop has actually has an impact on what the review could be, or whether or not like having a refund policy, that seemed like it would be something that would potentially affect the the seller's opinion. But yeah, this was just the stuff that I kind of targeted that I thought might be interesting. So this is the target distribution for all of the data in my data set. So this is a histogram showing the average stars per month. So obviously you can see that it's really heavily skewed to the right. So I kind of knew right away that that might end up being a source of error for me. So for my random forest, over here you can see on the right a screenshot of my Jupyter notebook that I used for building this model. I decided to use Grid Search CV, which is an offering from sklearn, to basically try out a bunch of different combinations of hyperparameters. And you can see my parameter space there of the different things that I tried out. So Grid Search CV you guys have probably used, but basically it just tries every single combination of these different features. So I ended up, because I did threefold cross-validation, I actually ended up with 864 different models candidates, and the best candidate you can see over there I have at the bottom. It figured out of these various different values that I had for the different features which ones were the best and came up with the best outcome given the data set. I talked to Dr. Wu because obviously my previous work that I researched didn't have exactly the same target, and also it used different data sets. So it was really hard for me to compare directly to that previous work. So he suggested that I train a couple of other models and compare those results to my random forest algorithm. So the first one I used was a multi-layer perceptron neural network using the MLP regressor class from sklearn. And then the second model I decided to compare to was a KNN, so K nearest neighbor, which we learned about in class. I ended up with n neighbors of 50, so this was like the total number of neighbors that it was using for each prediction. And I used Grid Search CV on these two as well. So here you guys can see the results. Obviously the random forest regressor did best in terms of the R-squared value. It still wasn't like really great. Obviously 0.4 isn't the best, and you guys will see why on the next slide. But it did perform a lot better than the other two models that I tried. So over here on the left, you can see I did some like histogram comparison between the ground truth. So this is like the real values for the target for the test data set versus the predictions. The predictions being like what my model predicted for those same records. So right away we can see that the predictions are still skewed to the right, but you don't see like that sharp peak. So it seemed to kind of like normalize it a little bit more. Over on the right, I rated like the feature importances. So this is just like how much correlation did these different features have to the target. And those top 10 on there, I will talk about a little bit more. So the top 10 most important features, that was kind of the thing I was trying to figure out based on the outcome of my model. So these were the things that I found that had the highest impact on the target in the prediction. So first being like the number of shop favorites, and this one I included because you can, obviously it's not completely seller controlled how many people favorite their shop, but what you can do is you can like offer coupons to people that favorite your shop and stuff like that, since you can see which users favorited. And you can like have a shop announcement that says, hey, if you favorite my shop, I'll send you a coupon and stuff like that. So I wasn't surprised to see that that one had such a big impact. The second one, whether the shop has a refund policy, made sense to me as well. The description length, you see a lot of different like lengths of these various fields on here. So obviously like filling in more information on your shop to make it more descriptive. And so people have more information without having to ask you seemed to be like a big factor. And then the number of active listings was also pretty high up there. So actually having like more distinct active listings rather than having, just like one listing with a bunch of customizations or something. And then, yeah, basically just like there's a couple down there kind of like at 7 and 8, the number of tags on the listing. So this is just like the number of different like descriptors like color or like style and stuff like that. You can enter a bunch of different tags so that when people search for that in the Etsy search, that it'll come up, your stuff will come up. So that made sense as well. The number of images on the listing, so including more images so that people can see like different angles and stuff, would probably make people think more highly of your shop when they're going to review. So obviously the R squared value, this is like kind of where I talk about like some of the stuff I think was wrong with my method. The R squared value was not very high, so there was definitely some sources of error in my method. One thing was I've already mentioned a couple times, which was that the data set was extremely skewed. So then obviously lack of knowledge just on my part of how to best optimize the model since I'm fairly new at data mining and stuff like that. I'm not really sure what else I could have done to make the my random forest model better, but I can try to research like how to make it work better for a skewed model, or skewed data set rather, that like I have. Was the target calculated correctly? I realized that I wasn't entirely sure whether there could have been some shops in there where they looked like they were active based on that algorithm that I used to determine, but were they actually active or were they just sitting around with, no, like maybe they have like a shop message that says, hey, I'm actually not accepting any sales right now, or if someone tries to make a sale, they would just shut it down. So it's actually kind of hard to tell sometimes whether or not a shop is like active. So I probably could have put some more thought into like how I could have determined that, maybe like grabbing their transactions and figuring out, when was their most recent transaction and using that as well, which is what I'll probably do in further research on this. And then finally, I didn't really consider the contents of the field. I just considered the length. So for example, like you could have a refund policy, but your refund policy just says, I actually don't accept refunds. Like, would that have the same impact or would that actually have a negative impact? So I think I could definitely do some work to like look at the actual contents and maybe rate it whether it's like positive or negative. And I think there's another research project doing a similar thing, but that might also like be some important information that could make my model better. These were kind of like the contributions I feel that were attained with my research in particular. So first of all, was just researching from a seller, like a shop seller's point of view, since I actually had an Etsy shop for a while, as opposed to Etsy's point of view. So I was coming at it from how can Etsy sellers make the most of their shops and make the most sales and have a positive impact in the long term by getting a good solid average review, and also just getting people to review their shop. And then also the second thing there is collecting a data set, albeit a modest data set of active Etsy shops, which isn't something I can really find online, which I think I'm going to make available. And then also I mentioned probably add to as time goes on. And then finally, determining which shop settings have some correlation to the average shop review. When I open my Etsy shop back up, I will look at that list and make sure that all of the stuff on there is optimized to the best of that it can be, based on my results. And then obviously, as I continue to do more work in this area, I can even do better with that. So thank you for watching.